Island, home to some of the most beautiful and historical architecture in America. Now meet the people who are revolutionizing this age-old facade.
This is the story of a brick. Brick is beautiful, and brick has been around for centuries. The heaviness of brick and having to put that on the outside of a building as a veneer becomes very, very complicated. It's very, very costly to build an energy-efficient brick building. Unfortunately, brick hasn't changed, but the way we build buildings has changed.
Clay brick's great once it's finished, but the whole process, transporting it, getting it on site, moving it, laying down the mortar, making corrections, if there's ever a problem, having to cut them. A lot of things can go wrong in the entire construction process.
In the brick business, the fastest growing part of the brick industry is thin brick. Brick's trying to get thinner. It's trying to get more lightweight, but it's still rigid, it's still heavy, and it still really doesn't have a place with the way we build buildings today.
So when a breakthrough idea was presented to the folks at Drive It, they knew it was going to be a game changer.
I said, "What do you think?" And he goes, "Wow, how come I haven't seen this before?" I knew right then that we had something that was pretty attractive to the market.
It's one of those things you look at and you say, wow, it's so simple. Why didn't someone think of this?
I tried to understand, how could we emulate brick? How could we make something that looks traditional but has the energy efficiency that is unheard of? So this is new brick. It's been in the works for about a little over 5 years now, and it's now part of Drive It's leap forward in the innovation and revolutionary new products. There's several problems in the construction industry, right? One is speed, and the other is ease of use. This brick takes care of those problems. This alignment guide is for speed. It creates its own horizontal joint, and it allows the brick to be stacked.
That lip, that patented lip, is really an important feature of that new brick. And it really is what is going to make the installer see the beauty of new brick, because he's going to install more brick in one day than he could ever install a clay brick.
So with clay brick, because you're using a lot of mortar, it's a lot of weight, eventually you have to stop to allow it to cure, usually waiting a whole nother day. With new brick, that's just not the case. You can just go as high as you can, as far as you can, with as much as you have.
Brick is held together by fire, and new brick is held together by chemistry.
To find out more about new brick, we're heading to the factory to see how it's made. The raw material is made with an XPS foam board.
When the sheets come in, they look like that. They come in pallets, and then go to a next step of cutting each one of them to stick length.
Extremely hot wires cut the sheets into sticks.
A pallet of extruded XPS will make 1,800 bricks.
The sticks then get their lip, or patented alignment guide, and it's off to the meshing station.
After identifying each one of the sticks with our patent number, we go into a meshing operation. The meshing provides strength to our stick and eventually puncture resistance to each one of the bricks. Our next step in the operation is the base coating of the sticks.
When it comes to options and custom colors, new brick's versatility gives architects the design freedom they never had before.
We have standard colors, textures, and finishes, but we can go beyond that. As long as we know what that customer need is, we can create that and develop that.
We received this sample from a potential customer. We go through the process of first matching for color, matching for texture, and after that process is done, we provide the sample to the customer that is a perfect match. After each one of the sticks has been dried with a finish coating, they go into our final cutting operation where each brick is cut to length. Follow me, I'll show you. We are now in our cutting station where we'll be cutting sticks into individual bricks. Each of our sticks will provide 6 bricks, and the operation takes about 5 seconds. Our final operation in the shipping department is palletizing. There is 6,000 bricks on this pallet alone, and then we're going to be doing shrink wrapping, and we'll be ready to ship.
Now the astonishingly lightweight pallets will be shipped and ready for install.
You know, what will be different with this versus conventional brick is, the fact that it's so lightweight, they can just carry this up the scaffold themselves, just bring it up in bundles. Each bundle has about 90 bricks. They don't need to have special scaffoldings to account for the weight of the conventional brick. So it just makes the whole process a lot easier, certainly a lot more ergonomic, because it's not as physical as installing conventional brick.
The application is very easy. It's extremely light, where we were able to lay about 200 bricks in about 20 minutes.
It's not only lightweight, but extremely durable.
One of the great things in modern day materials science is that you can see that the materials you choose affect the properties that you will see in a product. So one of the things we do here is we test things like impact resistance. So we have an instrument here that allows us to drop a set weight onto a material that we've created and allows us to see how it responds to that impact. I'm going to place the brick under this surface, and then it allows me to pick up the weight to a set distance. This is going to be equivalent to about 48 pounds per inch. And if I drop that, then we are able to see that the brick has no significant damage or cracking or breaking to its integrity. Now in comparison, if I show you a thin brick, I can take the exact same test apparatus, I place it under there, and if I lift it to that same amount of force and drop it on there, when we drop that, we can see that the material is brittle and will crack due to the nature of the clay material.
Prior to new brick, it was really difficult to, let's just take renovation as one example. It was really, really difficult to renovate a construction or a building that was already existing with clay brick.
If a clay brick breaks, it's a little challenging having to cut in, remove the old mortar, fit a piece in, remortar it. It's more time consuming than you would think.
Today, we have the ability to match how that brick looks on an existing building through our customization capabilities here at our new brick facility. So we have a team of folks who literally will take the existing bricks that come in and they will make our new brick look exactly like those bricks, so that when you renovate that building, you don't even know the difference. It just looks completely seamless.
Today we're making so many different textures, so many different colors, different variations, different shapes. These are all things that brick just simply can't do. With new brick, the owner's a winner because he gets an energy efficient building, he gets the look of brick, and that's really what he wanted. It's great for the architect because he can design a building much more easily. And then the general contractor, of course, can now construct a building, and he can do it in a timely manner, and he can get it done within budget. So whenever you can find a way that you can get more done with less people, it's a winner.